One very important feature of Red Hat Enterprise 4 is that the kernel that it comes with supports the Linux Logical Volume Manager version 2, or lvm2. Logical volume management is a widely used technique for deploying logical rather than physical storage. With LVM, logical partitions can span across physical drives and partitions and can be resized unlike traditional raw partitions. This gives us a lot of flexibility, especially when you run out of space. Let's say you ran out of space in your home directory and you had users that needed to put their data there. If you had a regular raw partition, you would have to put another hard drive in, then you would have to copy the contents of the current partition into temporary space, and then format the new hard drive and then move the contents over there and remount that. With logical volume management, basically this process becomes very simple, and it's just a matter of adding another hard drive and then creating a physical volume and adding the physical volume to the volume group that holds the partition. And actually with lvm2 you could do this all online while the system is running without bringing down any partitions or unmounting. Um, when it comes to LVM, you have three different layers. The first layer is the physical volume, which cannot span over multiple hard drives. So to span over multiple hard drives, you have to create a physical volume per drive and combine them into a logical volume group. A logical volume group is then divided into logical volumes, which are assigned mount points such as /home and file system types such as the extended 3. Let's take a look at our current partition situation. If I do an fdisk -L, you can see that I have an LVM partition here that I've set aside, which is about 700 megs. So let's create a physical volume on this partition. So to do that, we use the command pv create, and is dev sda5. So now that tells me that the physical volume has been successfully created. So now the next step is to create a volume group using the physical volume we just created. So to do that, we use the command vg create. We need to give our volume group a name, so we'll go with vol group 00, and the physical volume is dev sda5. Okay, so now we've created that, and we could actually do a vg display and the name of the volume group, which is vol group 00, to see the information on this volume group. As you can see, the volume group is 696 megs, so about 700 megs, and the physical extent size is about 4 megs, so that's each little chunk of it, which it has a total of 174 of these. So in our case, what we're going to do next is we're going to create a logical volume, but we're not going to give our logical volume the entire volume group size. We're going to give it about, let's see, so we have 174, so let's give it about 120 physical extents, so that at a later time, if I want to extend it, I can go ahead and extend it. So to create a logical volume, I use the command lv create. So lv create -L, and then the number of physical extents that I want to do. So I said I was going to do 120 physical extents, so that's 120 times 4 megabytes, which is about 480 megabytes of space. So the next thing is we need to give it the volume group name. So for that we put vol group 2, vol group 00, I mean, and then the name of the logical volume, which I'm going to name it log vol 00. And we'll go ahead and try to create that. Now let's say at a later date I wanted to add another hard drive to add more space to my volume, to my logical volume. What I can do is add another hard drive. Then I would again do the pv create on that hard drive to create a physical volume. And then I could just do a vg extend to extend my volume group. And then I can easily have more space created for my logical logical volume. Another thing you can do is, let's say you want to reduce the space, you could also do that. In this case, you would use the VG reduce to reduce the volume group size. So now we're just waiting for our logical volume to be created, and it has been created. So now, usually this creates a device, and the device takes the form of dev, and then the volume group, and then the logical volume group name. So what we're going to do next is we're going to format this um, new logical volume with the extended3 file system. So what we're going to do is do mkfs.ext3, and it's dev, and the volume group, which is this vol group 00, and then the logical volume name, which is log vol 00. So let's see if that works. Yep, it's working. It's formatting it. So once this is formatted, I want to mount this as my /data drive. So we'll wait for the journal to be created, and then we'll create a directory /data, and then we'll edit the fstab file to add this new mount point, and then we'll mount it and write to it. So this is taking a little bit of time to create, and we'll just wait. Looks like it's done now. So now what I need to do is I'll make dir /data, and I'll vi etc fstab, and what I'm gonna do is I'm gonna take this line here, which is the boot partition, and I'm gonna edit that line, and instead of boot I'm gonna put /dev vol group 00 / log for logical vol 00, and that's my device. And then for the mount point, it's going to be data. Data. And it is extended3. Trying to keep the same formatting. And it's extended3, and it's defaults and 1 and 2. So that's correct. So here's my device. Let's double check that. /dev /vol group 00, which is the volume group name, and then the logical volume name, which is log vol 00. The mount point, it mounts to the /data, and it's an extended3 and 1 and 2. So that's correct. So we'll go ahead and save that. Now after we save, we can run the command mount -a to mount all file systems available, and then we can do a df -a and see that we now have a mount point / data under that device. And we can go to /data and create any type of files there.